Remember last time we were talking about sequences and bushels of apples. Specifically, we were talking about arithmetic sequences. An arithmetic sequence is where you take a number and you add that same number over and over again to get to the next term in the sequence of numbers. So in this case, in this example with these numbers, that D number is 2 because we're adding 2 over and over again. So we had two different formulas, recursive and explicit, and recall recursive was where we tried to find the nth term using the n minus 1 term. And so what that means is we're trying to find some bushel of apples way off into the future. Maybe it's the 99th bushel or the 57th bushel. But in order to do that recursively, you have to know the 98th bushel or the 56th bushel. All right. In order to find the 100th term, you have to know the 99th term. That's how this formula works. The recursive formula says I'm going to find the nth term using the one right before it, and then I would just add 2 to that. All right. So if I told you that the 99th term was 400, you'd know to just add 2 and you get 402. That's how you do it recursively. Take whatever you had previously and add 2. But for the explicit formula was a little bit more versatile because you don't need to know the one right before. It's kind of nice. If I'm finding the 100th term, I don't need the 99th term. What you do in this case is you just take the first term, which in this example was 10, and then you're going to add that D number, which was 2, however many times. All right. So if I'm finding the 100th term, you'd have to add 2 99 times. n minus 1 would be 99. So for the 57th term, you'd add 2 56 times. That was arithmetic when we added the same number. Check out the difference in these numbers. Today's lesson, we're going to have numbers like this, and you should notice the pattern. It looks like this time, instead of adding 2, this time it's multiplying by 2. If you're multiplying the same number every time, that's a geometric sequence. And so we're still going to be doing the same type things. We're going to be looking for a recursive formula where we use the one right before it. And we're going to find an explicit formula where we use the first term and multiply. But we're pretty much doing the same type deal. The only difference is, the main difference is we're multiplying by 2 instead of adding 2 in this example. All right, so notice in geometric, this number is called an R number. It's a common ratio. Whereas in arithmetic, it was a D number. It was common difference. So ratio for geometric. Find the common ratio means find that number that we're multiplying by. So how do we get from this number to the next number to the next number? Well, it looks like we're just multiplying by, not 3, but negative 3. So we would say R equals negative 3. That's it. That's the common ratio. Find the next 3 terms. So I like looking at it like this. Fill in the blanks. What's next? Well, in order to do that, you have to figure out what they're multiplying by. It looks like they're multiplying by negative 2. So if we keep doing that, times negative 2 would give me negative 16. And times negative 2 would give me 32. And times negative 2 would give me negative 64. Same question. Find the next 3 terms. So again, we want to figure out what they're doing. How are they getting from number to number? Well, it looks like times 4, right? Times 4. Ooh, I don't trust myself to do times 4 on numbers this big, so let's get a calculator. 128 times 4. It's 512. And then take that number times 4. It's 2048. And then take that number times 4, 8192. Next, we want to find the recursive formula. So remember, in this case, the recursive formula, we're trying to find that nth number, or that nth bushel, but we have to use the one right before it. So for a geometric recursive, you're going to take the one right before it and multiply by that R number. So let's just see about this. We need to know that R number. How do we get from number to number? Looks like it's times -3. So that's really all we need here. The nth term is going to be the one right before it, n-1, times -3. That's all you have to do for recursive. So then the next one looks like you're multiplying times 3. So the nth term is equal to the n-1 term, the one right before it, times 3. Find the explicit formula. So I've got the explicit formula written over there in that box right there. You take the first term times r n-1 times. So let's see. A1, we need A1 in that formula, and A1 is just this one, the first term. So we're going to have AN equals that first term times R. Well, R is how you get from number to number. It looks like that's times 4. So times 4 to the n-1. That's it. That's the explicit formula. What's nice about that is you can just plug in and find any term. If I want to find the 99th term, I plug in 99 into my calculator. So you look at the next one. I need to know A1, that's 3. So I'm going to have AN equals 3 times, now I need to know R. Looks like we're multiplying times -5. To get from 3 to -15, and multiplying times -5. So let's put that in parentheses. So 3 times -5 to the n-1. Find the term named in the problem. I want to find the 12th term in this problem. So again, here was my explicit formula. This is what we're going to use. Okay, so for the explicit formula, just like what we just did on the last slide, we need that A1 number. A12 is going to equal that first number, -2, times the R value. How do we get there? Looks like it's times -2. So times -2 to the n-1. But n in this case is 12, so n-1 is going to be 11. All right, so that's going to be the number. Find the term named in the problem. I definitely want a calculator for this. I'm going to do -2 times -2 to the 11th power, 4096. So the 12th term, A12, equals 4096. So then the next one. Remember, we're using this formula for explicit. We want to find the 11th term, so that means the n equals 11. So A11 equals the first term's 4 times, okay, looks like we're multiplying by 3 here, so times 3 to the n-1, well, 11 minus 1 is 10. So that's what I'm going to do, 4 times 3 to the 10th power. 4 times 3 to the 10th power. 236,196. That's a big number. 236,196. The 11th term is 236,196. Number 19, in your first week of training, you can run 0.25 miles without stopping. You double that amount each week after that. During which week will you reach your goal of being able to run a full marathon, 26.2 miles, without stopping? All right, this problem is actually easier than you might think because I'm just gonna list out the terms. I know we start at 0.25 miles on that first week, and it says we double that amount each week after that. So let's just multiply times 2, right? Double it. So times 2 is 0.5. That's the second week. And then double that 1. That's the third week. Keep doubling it. 2 and 4 and 8, 16, 32. Aha, there we go. Remember, our goal was to get up to 26.2 miles, where we can see 32 is going to get us there. So think about it. That's the first week, second week, third week, fourth week, fifth week, sixth week, seventh week, eighth week. That's where we've met our goal. The answer, after 8 weeks.